Hi guys. If you didn't see in the last video, we went through a quick down and dirty process of making a friction folder in Sketchup. I figured since I've got the model up here, I might as well make a second video on how to prepare something like this for 3D printing. This is kind of an involved topic, and so I know that I'll probably be glancing over important details, and I apologize in advance. Use this as an ancillary video, an additional video to your study on how to make good 3D objects for 3D printing. So we're starting with what we finished off with, which is basically three elements of the model, and we're going to turn these into 3D objects. So the place we'll start probably is with the easiest one, which is the spacer. We'll just open that up, use the push-pull tool, and we'll push that up about 3 millimeters. Now, one add-on that I'm going to introduce to you, if you don't already know about it, is the solid inspector tool. What it does is it takes a component or a group and looks at it and sees if it is a complete solid object. And we'll go over what that means here in a second, but to use it, you go to Tools, click Solid Inspector, and it'll examine it and see if there's anything wrong with it. This is a very simple object, and so it didn't find anything wrong, which is great. Now I'll show you an example where something can go wrong. If we take this blade and open it up, and just make this into a three-dimensional object by pushing each of its individual components up 3 millimeters on all of these, then it looks like a solid object. But if we use the solid inspector tool, it's going to find some errors. It's found 3 stray edges and 13 internal faces. If you click on those things, it will, let's see if we can x-ray, it will highlight those points where it's found internal objects or other errors. In this case, we have actual internal faces. In reality, when this is 3D printed, the entirety of this interior space is going to be filled with plastic or a matrix of plastic. We don't want to confuse the modeling software by having these weird faces inside the object that really shouldn't exist. Similarly, it's going to look for stray edges. So if we click on that guy, it found just some errant lines out here that aren't three-dimensional at all. Now the Solid Inspector add-on can fix these objects or these errors, but just for the sake of completeness, I'm going to show you how to do that ourselves. So we'll Command Z just to move that back down to flat. And when we look at these, all we want to do is join up all of these individual faces. So we'll click on this line that doesn't need to be there and delete it. Click on this line, delete it. And delete these stray edges as well. And in reality, we also want to fix these sharp edges. Right? We'll go over that in a second here, but just for now, I'm going to push this back up 3 millimeters. Click out, select it again, Tools, Solid Inspector, and we've fixed all those little things. All right, so if we were to print this as is, we're going to have these real sharp edges right here and right here. That will print, okay, but you're going to have very weak points in your model. And in reality, this isn't what we want our knife to look like. We want some connections to be made here. But this will be a very weak point and a likely breaking point in your plastic. As a template, it's not a big deal. It just probably won't last very long. If you're making functional 3D prints, it's a big deal. So let's Command Z to get that back down to flat. And all we want to do is finish out this portion here with a simple arc. And then we'll delete these extra lines. Delete. Alright, that should be good there. Just for the sake of completeness, we'll go ahead and round out. There we go. This bit there. We don't really want sharp edges and angles. We do the same thing there. I'm going to leave it alone though. And then here we're going to get rid of this weak point by creating another arc somewhere out in here. And we'll delete those. Alright, so now we have smooth transition between our different angled parts. And voila, we can push this back up to 3 millimeters. And now we have a solid blade that will print fantastically. Lastly, we can do the handle. We'll go ahead and hide the blade and the spacer. Oops, you know what? I need to bring that blade back, and I'll show you why here in a second. But we'll enter in, this is going to be the hole for the pivot pin. Delete that. Now, we'll bring back the blade. And the reason I was doing that is because we need to use this pivot pin hole as a guide for where to put that same hole in the handle. So I'm going to go down to the bottom here, and you see that creates a nice little outline for me on the handle where I need to put that hole. So grab the circle tool and hover till we get that center point. Move over to that center point, move out to the edge, and voila, delete that hole, and we have our two holes cut out. Push pull, we'll bring this down 3 millimeters. Orbit it back around to a normal view, and we'll just solid inspect that to make sure everything is shiny. Alright, so you could at this point print out all of these little pieces. And I recommend you do print it out just as it is. One reason, if you're going to be using this for knife making, to print it out as is this gives you nice little points to drill your holes. Sometimes I'll even come in here, and I'm going to Command Z just to get back to a flat model. And we'll hide that guy. If I'm using this as a drilling template, putting this on a piece of steel and using it to index my drills or whatever, then I will take these circles and make a tiny little hole here, maybe a 1/16 of an inch, just enough to get a small drill bit through, and then use that as my hole. And so it basically is a centering template for a drill. I don't know if I explained that very well, but by creating these little tiny holes, you create pretty accurate points to index a drill bit to drill these out in your steel. If you do it with the same thing for the pivot pin, but once you push this out a ways, oops, and delete this line. I'm going to come down here. If you made this fairly thick, like say 8 or 10 millimeters, you can stick a 1/16 inch drill bit right through there. It's going to keep it nice and perpendicular, and you're going to be getting nice marks on your steel for exactly where to drill for your stop pin and your pivot pins. So that's just one suggestion. But if you're going to be making a template to test the ergonomics of your model blade, I have a different suggestion. And that is to make two versions of the handle, one that incorporates this spacer all in one, and one that also incorporates these pins all in one. I'll show you what I mean here. If we take this face, Command C, and then hide everything else, hide this, enter into this object, Command V for that spacer, and we'll move, I just connected the two. Command Z, Command V, move it off that space. There we go. Select it, move it, and join it to this object, this face. And then I'm going to close these circles. I know you may not be following exactly why I'm doing this here. I think it'll become clear in 1 second. Close this. Alright, just to recap. If you want to make a functional design template to test the ergonomics of your design friction folder, this is the steps I would follow. You make one handle that incorporates a spacer and these pins. So if we take our push-pull tool and move this guy up 3 millimeters, this guy up, say 5 millimeters, same thing here, 5 millimeters, actually let's do 6. This one up an extra millimeter, make that 6. and this guy up 6. And then this object is going to be full of errors. Let's see what Solid Inspector can do for us. Fix and fix. There we go. Alright, so by doing this, what we've created is a single printable object that can house both the blade and the spacer into a functional design template. I don't feel like I'm doing a very good job explaining that. Let me show you. If we unhide the blade, you notice if we printed this out, I'm going to move this up a little ways here. If we printed out this handle, this object, and this blade, then we would have two pieces that index into each other. This blade will slip over this little pin we've created, and you can rotate it and it'll stop on the stop pin. So you can put it in your hand and fiddle with it and see if you like it, see if there are any design changes you need to make. The problem that we're going to run into is that this blade is not going to fit very well over this pin because these holes are the exact same size. So we want to increase the size of this hole just by a little bit. So let's select that circle, click the offset tool, and increase this by, say, 0.2 millimeters. Probably 0.1 would be fine, 0.2 is safe. Use the push-pull tool to move this down and erase it. It erased itself. So now we have a little bit of space around this pivot pin so that the 3D model will move seamlessly and it won't want to get stuck on that pivot pin or snap off or anything. So if you printed out these two objects, you'd have a functional half-handled friction folder to play with to see if you like your model. To create the other side of the handle, all we have to do is make a copy of this guy and just flatten some things out. Push-pull this guy down to its surface, and then we'll take these. These actually need to be holes. So we'll take them all the way down to the other side of them all the way down. Orbit to the bottom because they didn't delete. Delete that. Delete that. Delete these little lines. Orbit back up here. We can delete these. It won't matter. Solid Inspector will fix that for us. And then just like the other one, we're going to have to increase these holes just a little bit. So we'll take that offset, move it out 0.2. Same thing over here. Offset, move it out 0.2. Use the push-pull tool to get rid of these. Double click should do that one. Oh, get rid of that guy. Oh, we made Sketchup angry. Command Z, Command Z, Command Z. Let me use the push-pull tool again and see if this won't do it here. Right there, that's not working. Sometimes Sketchup becomes finicky. Delete, delete, and we'll see if we can close this. This bottom, there we go, and again we're going to have to finagle Sketchup into working for us. Connect some endpoints, delete, alright. That should be the other side of our handle. We will see how Solid Inspector feels about it. Everything looks fine to it. Just because, I'm going to go ahead and get rid of these extra lines. Sometimes the printer will try to draw those lines on there. And then we can move this guy up to its that bottom point, isolate it to the z-axis, click there, that looks right. Okay, so now, oh, forgot, we need to extend these pins up a little bit. Up to there. All right, so now if we printed these 3 objects out, we would have a very nice little functional template of our knife. And because we've created a little bit of extra room here, they're going to index with each other very easily and let them move. You also might want to put a pin right here just so that these back edges don't want to move around and try to lever off and break these pins. But for the sake of cutting this tutorial off at a decent point, we'll leave it right there. Just a quick final note, in order to print these, you're going to want to put these all onto the same plane, the same Z plane. So I'll actually show you how to do that real quick. Make a rectangle, make it a group, grab these objects with the move tool, grab the bottom face or point on the bottom face and move them down somewhere on, actually I have to select this guy, move them down onto this little rectangle that we've created. Select, move, grab a point at the bottom. I'm isolating this to the Z plane, clicking the side there, and then we'll go to a top-down view, move, isolate to the green axis, isolate to the red, same thing with this guy, move, all right. So by moving them onto this little rectangle, we've ensured that they are sitting at the same space, same point on the z-axis. So your printer won't try to print these off of the actual work surface. All right, last thing we need to do is select all the components, make them into one group, and then go to File and Export STL. This is another add-on that you can get. Choosing that, export it as a millimetered object, name it, friction folder, save it, and then use your favorite 3D printing software to throw it out onto your 3D printer. Guys, I know that was real fast. I know that some of that was probably confusing. If you have any questions that I might be able to help you out with, just hit them in the comments below and I'll see what I can do. If you feel like this video is terrible, let me know and I'll try to do a different one that is a little bit more clear. All right, good luck with your printing.